It's lesson 10.6, Trigonometric Ratios, with an exclamation mark because this is exciting. So here's what was on the previous video too: sine, cosine, tangent. And this thing has really helped me, SOHCAHTOA. Helps you remember that sine is the opposite over the hypotenuse, cosine is the adjacent over the hypotenuse, tangent is the opposite over the adjacent. So remember, hypotenuse, it's the side opposite the right angle. So sine would be the opposite over the hypotenuse, cosine would be the adjacent over the hypotenuse, and tangent, opposite over the adjacent. I sure hope you have that in your notes. Now the inverse of the trigonometric ratios looks like this: sine to the -1, cosine to the -1, tangent to the -1, or the negative first. And that just means the inverse, and that can help you figure out the angle, measure of an angle. So if you look at our triangle over here, and if we wanted to know the measure of angle y, you could look at what you're told with the adjacent and the hypotenuse. That would be 8 over 19. So 8 over 19. Now adjacent over hypotenuse, I think that is the cosine. So you know the cosine of y is 8 over 19. Now if you do the inverse function of that, then you will find out the angle, or the measure of angle y. So 8 divided by 19 is 0.421, and if you do the inverse cosine of that, some calculators will have the ACOS, some of them might have COS, cosine -1. Could be a second function. We'll have to figure out. You have to figure out on yours how you can do that. And if I do that on mine, what I get is 65.1 degrees. So that would be this angle here, 65.1 degrees. Now that helps you do a lot of other things too, because now that you know that you have 90 and 65.1, and if everything adds up to 180, let's see, 90 and 65 is 155. That must mean 25 degrees, about. I got rid of the 0.1. Now that you have that angle, that can help you start to solve the others, the one other side you have, or you can use the Pythagorean theorem too. So for example, now that I know 25 degrees, and I want to know this right here, that is the adjacent line segment to this angle, adjacent, I can use cosine, not the inverse cosine. But now that I've done that, I can use cosine, and I can say the cosine of 25 degrees equals some number over 19, adjacent over hypotenuse. The cosine of 25 equals some number over 19. Now, when I put in 25 and do the cosine, I get 0.906, and that equals x over 19. Now, if I'm solving for x, I multiply both sides times 19, and I'm going to get the length of that side, which happens to be 17.2. And I checked, because I took 8 squared plus 17.2 squared, and I wanted that to equal 19 squared. To see if it worked, and it does. This part over here pretty much equals 360, and this equals 360. So that's a way you can start to solve a triangle. Which brings us to our next triangle to solve. The entire thing, all we have is we have three angles. We have right angle there. So we have the hypotenuse over here. And we have a 5 and a 12. So I'm going to see what we can figure out here. So I know that right now for C, I have, for angle C, I have let's try that again. For angle A, I have the opposite and the adjacent. So I know that that's the tangent. So I can say the tangent of A is 12 over 5. Now if I wanted to get the sine of A and the cosine of A, let's see, I want to do my little reminder down here. Hopefully I have that right. Opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent. Okay. Now I don't have the hypotenuse, so I have a couple choices here. I do know what the tangent is. I know it's 12 over 5. Now I could do the inverse tangent, or I could do the Pythagorean, the theorem I cannot pronounce, the Pythagorean theorem. So I might try both just to see what happens. So first, let me do this. Let me do 25, that would be 5 squared, plus 144, which is 12 squared. That's a squared plus b squared. That'll equal c squared. Now, I know that that's 169, and if I put in my square root of that, I get 13. So I know that that should end up being 13. But I would also like to try it as the tangent of A is, or the inverse tangent. So I want to do the tangent inverse of A is 12 over 5. 12 over 5, 2.4. So I'm hoping that this will get me on the right track to knowing all the other things. So I know I have the tangent. So I'm going to do the inverse tangent of 2.4. So put my inverse tangent in, and I get 67.4. So that tells me, remember, the measure of this angle. And that would be a 67, not a 64. 67.4. Now, if our angles are 90 and 67.4, then that means our other angle has to be, pencil, 22.6. So now we have all three angles. And now we can use, again, we already used the Pythagorean theorem to get that 13. We have other ways of doing this now too. So if we have an angle like B, and we know that we have B, an angle for B, and we know we have the opposite and the hypotenuse. Let's see, opposite and hypotenuse. Oh yeah, that's the sine. So the sine of 22.6 should equal 5 over 13. So let's try that and see what we get. Now, if you do 5 divided by 13, you do get 0.384, and if you do the sine of 22.6, you get 0.384. So our 13 is correct. But we can solve it to find 13 without knowing what the 13 is. So let me do that too. So let's just make this and pretend that it's x for a minute. Now, this one is 0.384. Now the hard part here is we have x on the bottom. So I should multiply both sides times x, and I'll get x equals 5. And you still have that 0.384 over here. 0.384. So now I'm going to divide each side by 0.384. 0.384, and I'm really hoping that if I go over here to my calculator and if I do 5 divided by 0.384, I'm going to get 13, and that is what I get. So you have a lot of ways to solve a triangle. Now some of the examples on your lesson will just say find the sine of 30. You type in 30, you hit sine, and you get the answer, 0.5. And that's it. That's all there is to it. Number 27. Now number 31, these are some of the ones where they say solve the triangle. So you need to find all the sides. So we have angle Q, which is 14 degrees, and we have an adjacent angle here, or an adjacent line segment, sorry. So we could do opposite over that. That'd be nice, because if I'm having this is the x, that'd be x over 7. So let's see, opposite over adjacent. I believe that is the tangent of 14 is the opposite over the adjacent, because that would be the TOA part. Oh, I don't have my things written down. So, TOA. Alright. Yeah, opposite over adjacent. That's right. Okay, so now, if I do the tangent of 14, and that tells me it's 0.25. 0.25 equals x over 7. Now I should multiply times 7, and I'm going to get 1.75. Now that you have another side, we can do 7 times 7, 49, plus 1.75 squared, and that's 3 basically. So 49 plus 3, 52. 49 plus 3 is 52. I take the square root of that, and I get 7.2. And so that is now the hypotenuse. So I have all three sides, and now I also know another angle. So I have 90 and 14, that's 104. So I'm pretty sure that this is 76. Whoop, how about 66? Can't subtract apparently. Oh, I was right the first time. It is 76. Because 90 plus 14, 104, 76. So that's the goal when you solve a triangle. You need all three sides and all three angles. Now in 37, this is this triangle. You've given two sides. You are given the hypotenuse and another angle, or another line. Why do I keep calling angles? Another line, and there you're told to find angle J. If you're told to find the measure of an angle, then you're going to need to use an inverse trigonometric function. Let's see what we have. So right now I have the opposite of J over the hypotenuse. Okay, so let's see. I gotta put my things down again. So I'm ready now with the sine of J, because that is going to be the opposite over the hypotenuse. And so if I have 15 over 17, which hopefully you're beating me done with some of this, that is 0.882. 0.882. And if I take that number and if I do the inverse sine, I will get an angle of 61.9 degrees. Which your book says is correct, but it says to the nearest degree, which would be 62 degrees. So, anytime you're asked for a measure of an angle, it's pretty much looking for the inverse sine or inverse cosine or inverse tangent. Okay, last example, I promise. This one says find the sine of A, the tangent of A, if the cosine of A is 3/4. Okay, alright. So, put my little things down here again. So, the cosine of A is 3/4. So that means the adjacent over the hypotenuse. So the hypotenuse is 4, and the adjacent one is 3. So now that I know that, I can first of all find the opposite side. So let's see, 3 times 3 is 9, plus something squared equals 16. 16 minus 9 is 7. If I subtract 9 from each side, so I get x squared is 7. So x is square root of 7. So that means this side is the square root of 7. Okay, so now I have that side. I can find the sine. The sine of A is, if I remember down here, opposite over hypotenuse. Let's see, opposite of A is square root of 7/4. And then tangent of A is opposite, square root of 7 over adjacent 3. Now, those answers are correct, and that's it because we don't have any radicals in the denominator, so everything's good. There you go. Let's go to the next thing. I'll show you the assignment. So your assignment is page 660 to 661, numbers 18 to 48, even. There you go.